TechDaily.ai, your source for technical information. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Okay, let's kick things off. It might actually surprise you, but even though the C programming language, powers a ton of the tech we use daily.
Really a massive amount.
Right. Its popularity in some developer surveys is, well, only just a bit ahead of C++. We found one figure suggesting maybe 2.7% more popular than C.
Which seems low, doesn't it, given its reputation?
It does. So that got us thinking, where is C still, absolutely essential? What are those crucial roles it plays that maybe aren't obvious? So today we're really going to dig into that, uncover C's hidden fingerprints all over our modern world, and show how this foundational language is, well, still the bedrock for so much.
And it's fascinating, because C is often working totally silently in the background. In systems we just trust.
Implicitly.
Exactly. So our goal today is really to give you a clear picture of why it's still so vital here in 2025. And we've got some pretty compelling examples that go way beyond just old legacy code.
Yeah, definitely not just maintenance. We're talking active, critical stuff in cutting-edge tech.
So where should we start? How about something really fundamental? Democracy.
Oh, good one. Elections. It's highly probable that when you vote, the machine counting that vote, it's running software written in C.
Most of them.
The vast majority. There are a tiny few that might use assembly language for very, very specific low-level bits, but C really dominates there.
And the why behind that, as we found, it really boils down to C's relationship with the hardware itself, right?
Precisely. C is what we call a low-level language. That means it gives programmers really fine-grained control over the computer's hardware.
Like memory, the processor. Exactly. Direct interaction. And something like vote counting, that's not just about being efficient. It's about creating a system that's highly auditable, very predictable.
Fewer layers where things could go wrong.
You got it. Minimizing abstraction. That direct hardware access is just key for sensitive applications like that.
Okay, so from ensuring elections run smoothly, let's pivot a bit. Robotics. You see those amazing robot arms in factories doing complex stuff. What language do you think makes them tick?
Well, C seems like the obvious guess, right? Given what we just said about low-level control.
Yeah, that's what I'd assume.
But here's a twist. The majority of robot companies, they actually use their own proprietary languages. Or robot-specific ones, like Inform, Carol, Rapid, things like that.
Oh, interesting. So C isn't directly programming most industrial robots then?
Not usually, no.
Yeah.
But, and this is a really interesting part, the syntax of many of these specialized languages, it often looks a lot like C.
Oh, okay. So they're built on similar ideas.
Kind of, yeah. The foundational programming concepts, the way you structure things, it's often very deeply rooted in C. So even if the final code looks a bit different, knowing C makes understanding those robot languages much easier.
Right, that makes sense. A common foundation, even with specialized tools on top.
Okay, let's shift gears again. An area where reliability is just paramount. Life or death, even. Medical tech.
Yes. And this is where C's robustness and efficiency really come into play. Think about BlackBerry QNX.
BlackBerry, like the phones.
They were famous for the phones, yeah, but their QNX operating system is something else entirely. It's designed for microkernels, a very secure OS architecture.
Yeah.
And guess what? It's built using C and C++O. And any apps developed for that super reliable OS, they also have to be written in C or C++O.
So critical medical devices, things that absolutely cannot fail, could be running on systems built with C at their core.
Absolutely. It shows the incredible trust placed in the language for these high-stakes situations. And related to that, Johnson & Johnson, huge company, right?
Historically, they relied heavily on C for a lot of their software. Now, it looks like their hiring is shifting more towards C++E, which might suggest a transition.
Okay.
But their past reliance on C in critical areas really underscores its importance in sectors where stability is just non-negotiable.
It really paints a picture of its long history in these essential fields. Okay, now, something billions of us use every single day, probably without a second thought, are computer operating systems.
Oh, yeah. If you look at the big picture, C played a truly foundational role in developing the major OCs we all use. Linux,
right.
Windows,
Yeah.
and Mac OS.
Wait, seriously? The actual core of these massive systems. Significant parts are C.
That's right. Now, they're not entirely C, obviously. Modern OCs are huge and use lots of languages. But major components, especially the kernel,
The heart of the OS.
the absolute heart, yes,
Cool.
and core utilities, often written in C. So, yeah, billions of computers worldwide are fundamentally relying on C code just to function.
That's just a staggering reach from our desktops to, well, let's go even bigger, space.
Ah, the final frontier. Yeah, C has been pretty much the go-to for many space programs. NASA's a big user.
Examples.
Okay, get this. The Mars Curiosity rover. You know, the one driving around on Mars?
Yeah, amazing mission.
It's flight software. The code controlling its incredibly complex landing and all its movements up there. Written in C.
Wow. And that mission cost, what, billions?
Around $2.5 billion, yeah. So a multi-billion-dollar robot on another planet steered by C code.
That's incredible.
And here's a fun little detail. A few months after landing, Curiosity had some operational glitches.
Oh, dear. Miles away.
Right. And the fix that got it working again. A simple reboot.
No way. Just turn it off and on again.
Pretty much. Which, speaks volumes about the underlying stability of that well-tested C code base. It's interesting, though, while C handled the core controls, they used other tools like MATLAB for, the heavy data analysis and simulations.
Okay, so C for the essentials, other tools for specialized analysis. Makes sense. What about other agencies? Europe, maybe?
Yep. The European Space Agency. Their Rosetta mission. The one that orbited and even landed on a comet.
Unbelievable achievement.
Also relied heavily on software written in C. So yeah, from Mars to comets millions of miles away, C keeps proving itself in the extreme conditions of space.
Okay, bringing it back down to Earth, maybe something less glamorous, but just as vital. Infrastructure, like traffic lights.
Exactly. Think about it. They control the flow of traffic, manage timings, sequences. It has to be precise.
Or chaos ensues.
Right. And many of those traffic light controllers, they run on software written in C because C allows for that predictable, efficient execution. It's perfect for these real-time control systems where tiny delays matter.
It's almost invisible, isn't it? C just orchestrating things behind the scenes, and it's not just traffic lights, I assume.
Not at all. Look inside your car. C is working away in lots of critical systems. Anti-lock brakes, the ABS,
Safety feature.
and the engine control unit, the ECU. These things need super fast, precise responses. C is a natural fit.
And it goes beyond cars, too, right? I think I read about aircraft.
Absolutely.
Wow.
Even highly advanced military jets like the F-22 Raptor, it's flight control software, written in C.
Wow.
The level of precision and just unwavering reliability needed there, C is often the logical choice.
So, cars, fighter jets.
Yeah.
Okay, what about the sea? Keeping ships on course.
Good question. There's something called OpenCPN. That stands for Open Chart Plotter and Navigator.
Okay.
It's open source software widely used on ships for navigation. And what's really cool is it was developed by sailors.
By sailors themselves. That's fantastic. Addressing a real need.
Exactly. And if you were to peek at the source code, say on GitHub, it's overwhelmingly C language files.
Really proved the point, doesn't it?
It absolutely does. It just highlights C's dominance in developing crucial navigation tools where, again, reliability and efficiency are key for safety at sea.
Okay, so let's just quickly recap this deep dive. We've seen C basically controlling, well, everything. Vote counting machines.
Robots in factories, though indirectly sometimes.
Right. Critical medical systems, the core of our operating system.
Spacecraft exploring Mars and comets.
Traffic lights, the brakes and engines in our cars, fighter jets.
And even the software guiding ships across the ocean.
It truly has this astonishing, often unseen reach. It controls everything from road, water, air, and space.
It really does. It's quite a testament to its enduring power and efficiency that C is still so vital across the board.
But one thing it cannot control is you. And you are only controlled by she, not C.
Huh. An interesting thought to end on.
It is, isn't it? Think about the human element, the ingenuity behind all this tech and the choices we make. The sheer pervasiveness of C, though, it really opens up so many avenues for, understanding the foundations of our tech world.
And it raises a question for you, the listener, to ponder. With such a foundational language underpinning so much critical tech, what are the implications moving forward? For security, for reliability, for innovation? Definitely something to think about.
TechDaily.ai, your source for technical information. This deep dive was sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance in public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.